Okay. And do I have everything? I do. Good. Okay, why is this case number 53? 53 is the port number for DNS. Very good, very good, very good. I'm not as smart as Marcus. Marcus brings candy. I would throw candy, but I don't. I didn't bring candy. So anyway, so the big thing about DNS is that pretty much if DNS stops working, everything stops working. If you can't get to Facebook, which is a crisis, right? Then that would mean that that possibly that DNS isn't working on one side or another. Okay. Same thing for Active Directory. I am going to be talking about the most basic of basic things in DNS, and yet it will provide you with the infrastructure, the basis that you need to be able to attack any DNS problem. I have talked about DNS for days, so this is what I can do in 75 minutes. My plan is going to be, we're going to talk about how DNS works. We're going to start from some incredibly basic stuff for a few minutes. We're going to do a very simple query, and then we're going to analyze it. And we're going to find that one very simple query extends to looking after the most complicated ones. I'm going to convince you that there's some great tools out there. Two free ones off the top of my head are Network Monitor, and the other one's called Dig. Now, everybody's heard of Network Monitor, right? How many of you have big, come on, what is this? Everybody, none of you, like it's really hot here, we're kind of sweaty, I don't want to put my arm up, so okay, that's might be a nice thing. Anyway, so, how many of you use Netmon? Really? Oh, okay. Wow. Usually the question is, how many of you tried Netmon once, looked at it and said, eek, and then closed it down and said, not doing that again? Okay, well, good. This will be an easier sell than it normally is then. We're going to do some Netmon. We're going to resolve a DNS address, and I'm going to then say to you that there's lots of ways to approach troubleshooting. One of the ways I do, because I'm not that smart, is that if I can understand how something works, then I can understand how it does not work. I'm going to argue, let's see how healthy DNS works, and if you know what healthy looks like, it's easy to see what not so healthy looks like. So that's my plan. We're going to do reviews and queries. We're going to look at the insides of packets. Once we've taken the basic stuff, I'm going to take you down to the bare metal in a DNS packet. It's pretty easy, as it turns out. We're going to learn DNS details. We're going to learn about QA. There's one Q and three A's. There's one Q and three A's in every DNS query. And then from there, I want to talk to you about something called eDNS, extensions to DNS. eDNS has been around since 1999. It was first created in RFC 2671. I know. What's wrong with him? He knows RFC numbers. That's so sad. I know RFC 1997. You know why? Because RFC 1997 was done in 1997. Only one RFC did that. It's not very interesting, that RFC, but it's interesting. I would have saved that for something really important. So, with the time we have left after that, I want to show you some tools. And the one in particular, I'll bet you know DC Diag. DNS lint is great. I'll mention that also. But the one I want everyone to walk out of here saying, oh, crap, I got to have that, is Dig. I'm going to show you how to get Dig and how to make use of it. It's a terrific tool. In the process, we are going to pick on security people. We're going to pick on security. I'm a security person, so it's okay. How many of you are security people? Come on, it's all right. I'm going to give you guys a hard time. So I'll apologize up front, but I do it too. And we're going to talk about how firewalls damage DNS. And that's what we're going to do for today. Does that sound like what you'd like to hear? Yes? Okay, thank you. Because I know there's a lot of great talks that I'm up against. A lot of great talks. My friend Ulf is doing a talk right now on something. AD, what's new in AD. So lots of other great things you could be at, and you're here. Thank you. I'm going to be doing some demonstrations. I do not like the fact that in the last 5 or 6 years, I see people come up and say, well, this is my one PowerPoint. I'm going to demonstrate for 75 minutes. And I walk away saying, gosh, they're smart. I couldn't do any of that. So all of my demos, the step-by-step is here. So you can go back and rebuild this stuff for you. Also, you'll have my email. My email is help@Manasseh.com. I tweet on mManasseh, so I'm easy to get a hold of, really. I mean, how many of you, anybody emailed me have I helped? Okay, good. Sorry. I will always answer. Many times the answer is, damn, I don't know. But, that's all I can do. So if we want to get things rolling, then we'd like to know what's going on in the logs. In DNS, Microsoft gives us some very, very, very extensive logs.
If you right-click on the DNS server, there's some tabs that come up, and one of them is logging. Everybody know that one? Logging. And it's got 64 checkboxes. And if you check them all, man, you get a lot of logs. But let me ask, how many of you are full-time DNS administrators? That's all you do. Really? That's pretty cool. That would be a great job. I want that job. No, I'm serious. DNS rocks. It's very cool. It's a lot of fun. You know, it's the sort of thing. Now, see, I've been single for about 1.5 years now. And, but when I meet women and they say, what do you do? Like, I'm a full-time DNS administrator. That has never impressed a woman ever, anywhere. But, you know. But the look of disdain is not as bad as the one, what do you do? I'm a computer journalist. Oh, it's exciting. Check. You know, so anyway, the reason I ask that is that, look, almost none of us do DNS full-time. So when I'm doing some mildly basic stuff for a few minutes, I'm just trying to wake the neurons up. I'm just trying to wake the DNS neurons up, okay? So let's take a look at that log. Let's see how useful this log is. That looks pretty interesting to me. Look, there's flags and response. I like response. And hexadecimal, that's good. And then 5 yahoos and 3 coms and a 0. And maybe it'll get better. Hang on. Some more yahoos. That's kook. Okay. And then, like, I'm cooking, you know. But anyway, so, and, oh, man, I'll tell you. So that log looks goofy. It's actually a great log. It's a great log because if you understand how DNS packets work, you'll say, wow, that's kind of awesome, you know. Has anybody turned this log on with all the checkboxes? Do you leave it that way? We can't do that because it generates 5 gigabytes of log every day, but, you know, it can be useful. Can be useful. So to make sense of that log, we need some background. So let's do a very, very, very simple query. Simplest query in the world. Let's say I have a computer called PC1. And by the way, I'm going to make this so simple. We're not even going to talk about you in your office. We're going to say you at home. Okay, so you at home. Everyone has a network at home, right? Just checking. Okay. Just want to know. If anyone doesn't, that's okay, but we wonder about you. And and let's say your machine at home is called PC1. And it's connected to the internet, and you probably have a router of some kind, a Linksys router or something like this. Does all sound familiar? Wireless, wired. How many of you wired your house because Cat5 is really better performance than that wireless stuff? Come on, admit it. That's my people. My people. Seriously, people come to my house and I say, by the way, this is your room. There's the 12-meter cable that you'll need to connect to the RJ45, so you know you can. You need that. And also, so I'm going to have you resolve this, a.bigfirm.com. I know that I'm supposed to use my examples as Contoso, but I don't like Contoso. No, I don't like the name. It's sort of like, you know, so Mark, what's that thing? I don't know. I got a little Contoso. I'm going to put some lotion on it. Just, you know. Also, I'm an American. I'm an American. You figured that out. And so my background, like about 1/4 of my background is Italian, but the last name is Italian. So Contoso sounds to me like a vaguely anti-Italian American defamation law. So I went out and registered bigfirm.com a long time ago because it just seemed like, you know, it's just me, but I thought that's a big firm, you know. So, and pathetic. And this is a special record. A.bigfirm.com is a special record. I built it, and you can use it as a troubleshooting tool. I'm not going to tell you why now, but soon, okay? So we look at this very simple query, all right? So first of all, what are we searching? We're searching a public DNS hierarchy. DNS, in some senses, is incredibly cool. Just step back and think about this. What is this big in terms of a single hierarchy? Just about nothing. I mean, how many machines are on the internet at any moment in time on the planet? I don't know. But if you told me it was 2 billion, 3 billion, I could believe that, including mobile phones. So the fact that we have just one hierarchy is pretty gosh darned impressive. So right up top, the top of the DNS hierarchy, again, this is like the level 50 part, the level 25 part, is that, so it's a DNS tree. This is a tree that is written by a techie. How do I know it's a tree written by a techie? Because only techies write trees where the roots are in the air. Okay, so it's true. It's true. That's just because we are three-dimensional people. We don't think in terms of up and down and stuff like that. You know? We're like four-dimensional. So, now, right up top is called the root, unless you're from certain parts of the United States, in which case it's the root. And so that there, we don't write root, we just use a dot. And then below that are the so-called top-level domains, or TLDs, .com and .net. You know those ones. .dk or .uk or whatever. And did you know? Now, by the way, who makes these? Remember about 8-10 years ago, they came out with some new ones. .aero, .museum, .biz. Boy, they were a big success, huh? You know who runs this? It's an outfit called the ICANN, the Internet Corporation for Assigned Names and Numbers. The way they've been running some things, I can't would be a better name for these guys. But, however, big thing happened last year. Did you see what happened with TLDs? You can build your own top-level domain. So if instead of being www.manasseh.com, I can become www.manasseh. That would be like a whole new top-level domain, like right there. No, as a matter of fact, I would move the UK over. Sorry, British guys, sorry. Manasseh would go like right there. You can have this, and you want to hear the price? Such a deal. Such a deal. It's $185,000. That's like 17 euros. And so 25 pounds, you know. And so if you strike it rich, and you're not a car guy or woman, you know, if the Ferrari won't do it for you, you just get yourself a TLD. So right up top there. And then from there, and they'll change all the routers, and it'll, you know, sorry, for some of you guys, the routers, and so that way everyone knows what I'm talking about. And then next level down, second level domains. And these are the ones we deal with. Microsoft.com, Google.com, stuff like that. Sorry, not Google.com. I meant Bing.com. I meant to say Bing.com. No, I will submit my PowerPoint decks to the Microsoft guys. They'll check to make sure I didn't say something stupid. And if I say Google this, they'll say, Google, what's that? So I have to get to change it to Bing. And so I'll say, well, Bing this, and when that doesn't work, then Google it, and it'll be just fun. I love this story. Where does Bing come from? I've heard 1,000 stories. They're probably all wrong. But my favorite is a story that says that Bing stands because it's not Google. I don't know if it's true or not. I didn't make that up. It's just something I heard. People tell me things. People tell me things. Somebody told me something yesterday. So it's not my fault. You didn't hear it from me. Something big's going to happen on July 5th. So next, once I have a domain, that's just a rumor. But if server interests you, keep the day open. So the top-level domains, okay, once I have a Manasseh.com, I can then break it down further. I can create a subdomain. So, for example, Manasseh.com is in two places. It's in Virginia, and it's in North Carolina. And so if I were to create the world headquarters, hq.manasseh.com, I could do that. So you with me so far? We've got our top-level, we got our root, our top-level domains, our second-level domains. What do we call these things down here? Think about this. What do we call those things down there? Are they called subdomains? Are they called third-level domains? Are they called child domains? What do you think they're called? Let's take a poll. How many of you think they're called third-level domains? Really, nobody? This sad little option has no takers? No champions. All right. How many say it's a subdomain? Subdomain, that's what it's called. That seems reasonable. How many go for child domain? How many go for the consultant's answer? It depends. What's the charge code? How many go for consultant's answer? You quavering bastards, you. How many go for, I don't know, Manasseh, that's why we hired you? Okay, that's right. These options are mutually exclusive and collectively exhaustive. I love that phrase. So let's try it again. You got to raise your hand once. Third level, anybody? Subdomains? Come on. Child domains? Okay. It depends. I don't know. Okay. Good. So to find out, I downloaded every RFC about DNS. and I searched for the phrase third-level domain, subdomain, child domain. Here's what I found. It's a 50-50 split between subdomain and child domain, so they don't know either. That's true. This is what I do for you guys. This is absolute truth. Okay? So we talked about that. So, all right. So here's my scenario. My scenario is I had a computer called what? PC1. And I was going to say, PC1, resolve a.bigfirm.com for me. Well, the first thing we need, though, is a DNS server. Where does PC1 get its DNS server from? Think about that for a minute, you know. Well, for example, so it's your house, not your office. How many of you have a DNS server in your house? My people. Those of you that don't have a DNS server, it's awesome. It's very cool. Because like for me, my location in North Carolina, this particular town that I have a place in North Carolina, it's sort of the middle of nowhere, you know, sort of the middle of nowhere, you know, right around the H. And no one gets that joke. And so a very common compliment in this town is, that's a lovely tooth you have. You know? So anyway, so these guys, this is they're Charter. Is anybody here from Charter Communications? No? Let's talk about that. So a lot of times, like, I'll think I can't get outside, but I'll ping. How many of you have the IP address of a DNS server on the internet memorized? Yeah, exactly. So I do GE, 4.2.2.2. And I'll ping GE, and that works, but I can't resolve, which means their DNS server isn't working. That's why it's nice to have my DNS server in the house. You know? Also, it's right there in the living room, so when people come in, it's like, what's that? Oh, that's my DNS server. Never get any second dates. I never get any second dates. So, but seriously, so I want to ask you, this is a question I get a lot on the AD side and just on the internet side. So let's just say I've decided that I want a DNS server. I want my own DNS server. I take a Server 2008 R2 box. Naked. I just build it. I don't even give it a name. I give it that really cool random name that Windows comes up with. You know, HH1R72-3, that one. So I don't change the name. I don't give it an address. I don't give it a static address. It just got that address from my router. I point my workstation to that. I turn on the DNS role. I don't do anything else. So I install Server 2008 R2 naked. I turn on the DNS role, I point the machine at it, and I try to resolve a.bigfirm.com. Does everyone understand? All right. Will it properly resolve that address? How many say yes? That's all the configuration there. How many think that that's it? That's all you need? All right, because that's not much, right? How many say, no, Mark, we got to do some other stuff, dude. Like, we're going out on the internet and things like that. Come on, sorry, have the courage of your convictions. Okay. The interesting answer is that actually this is all the configuration that you need. This surprises people. They say, well, don't I need a static address? No, you don't need a static address. I mean, you need the correct address, but you don't need a static address. What do we have to do? I mean, it's got to be connected to the internet. Why don't we have to tell it anything else? What's the name, being DNS experts, what's the name of that magic file that makes the DNS server able to search the internet? The root hints file. Every DNS server that I know of every kind, comes with this file built in, called the root hints file. That make sense? Okay. Anybody have a question about this, by the way? Really? None of you? People often ask me, that's your home network and it's a 10 address? Like, dude, you know. Because you fire up routers and what do you get? You fire up a router, you get 192.168. Mine are 10. How many of you have a 10 network in your house? See? Oh, I knew that was my people out there. Part of it really is that, again, you know, I've been single for a while, and so I'm trying to find a filter that will find the right woman. And so I'm thinking, my thought was like, by the time you get to the third date, you know, where it's the time where it's okay to invite her over to cook dinner because she doesn't think you might be a serial killer. And so, no, because I'm like most techies. All techies do at least one of the following three things. Ready? Cooking, music, photography. Did I get everybody? Did I? How do you know this? It's very simple. Cooking, music, and photography are the same three things going for them. You have to learn new stuff. That's one thing about IT people. We don't get to let our brains rest. We're learning new stuff all the time, so we don't mind. Photography, got to learn stuff. Music, got to learn stuff. Whatever, you know. I do cooking and photography. When it comes to music, I couldn't carry a tune in a bucket. So, but the other two I got. That's the first thing. Got to learn concepts. Second thing is you got to buy toys. You know, we're used to that. You got to buy good pots, good pans, good photography. How much money can you spend on a camera? My God, lots of money. How much can you spend on a guitar? Forget about it, you know. So, oh, and the third thing is that that's not enough. There's still some art. There's still some art. You know, simply having a cookbook doesn't make you a great cook. Simply having a book on photography or a set of notes. So, anyway, so I'll be cooking. So the idea is, I figure while I'm cooking, she'll start up her laptop because, you know, she's got to be technical, right? Technical people don't get non-technical people's stuff, right? And so she'll start up her laptop. She'll be that kind of girl, you know. And she'll notice a few things. First of all, I have an IPv6/64 network in my house. Routable, which means she'll notice she has not one but two routable IPv6 addresses. That will impress her. She'll know it's routable because it starts with 2. 2 means it's routable. But then she'll notice the 10 address. She'll turn to me and smile, and that'll be it. That's all there is to it. So, all right. So, let's talk about how this recursion goes. So, PC1 found a DNS server. How did it find the DNS server? Typically, we get it off a DHCP server, right? But why do I say that to you? That's a troubleshooting point. I mean, how many times do you run into something stupid where for some reason some client or some server isn't getting its IP address? Here's a thing I've seen people do in the past. They'll turn off all the unnecessary services, And they've got a static address. What ends up happening there? What happens if you have a static address on your server and you turn off the DHCP client? DNS registration doesn't happen anymore. Dynamic DNS registration doesn't happen anymore. That leads to some fun stuff, right? So, all right, so it's either configured statically with DHCP. PC1 asks its DNS server, and let's just call it ISP DNS. Let's say that ISP DNS goes to look up the IP address of a.bigfirm.com. So that's the first thing. We have our workstation, and our workstation is asking its local DNS server. The local DNS server doesn't have the answer. It might. And by the way, when I say the local DNS server, it's either the one in your house, if you're like me, or it's your ISP's DNS server, which is why I'm calling it ISP DNS server. We good so far? This is easy stuff. The ISP DNS server probably doesn't know what a.bigfirm.com is. If it already knew, why would it already know? If someone had asked for a.bigfirm.com recently, once this ISP DNS server goes and looks that up, it keeps it where? In its cache, exactly. Interesting question, though. If the ISP's DNS server has looked up a value, how long does it remember it? TTL, exactly. It's not a fixed amount, right? It's not an hour. It's not 3 months. It's if you ask my DNS server for a question, my DNS server gives you an answer and says, by the way, that answer is good for an hour, a day, whatever. It's called the TTL, the time to live. How long is a typical TTL on the internet? I hear 6 hours. I'd say anywhere from 1 hour to a day. I think a day is pretty common one. Now that's good, because that means if I'm an ISP DNS server, first thing in the morning, I've just been rebooted, because that's when we reboot the servers or whatever, then first person asks me for www.microsoft.com, I've got that in cache, and I don't know what Microsoft's TTL is, but let's say it's a day. That means for the rest of the day, if anybody asks me www.microsoft.com, I don't have to go look it up, I got the answer. That make sense? You knew that part. Here's the part I'm not sure you know. Let's talk about Active Directory. Active Directory lives and dies with DNS. What's the TTL in Active Directory? There are several TTLs. Most of them are 15 minutes. Some of them are 20 minutes. Whoa, hang on. What does that mean? That means that even though zillions of computers are asking the same question, where are the DNS servers? Excuse me, where are the domain controllers? You'd think the DNS server would have that answer right there. But because the TTL is so small, it's looking it up all the time. Therefore, my friends, I'm telling you that your DNS servers inside your Active Directory are some of the hardest working DNS servers in show business, because they can't rely on their cache. They're looking up and looking up and looking up. This is another reason why optimizing your DNS servers, even the internal ones, is very important. Does that make sense? Okay, good. Let's keep it up. So it goes to the top of the DNS hierarchy, and within the DNS hierarchy, there are 13 DNS servers. There are 13 root servers, they're called, and the 13 root servers, there's not really 13, but we'll talk about that, okay? says, what's the IP address for a.bigfirm.com? Now, those root servers, and it's a dumb request. It says, hey, root servers, could you go look this up for me? How many root servers did I say there were? For the whole planet? 13. Those 13 servers don't have time to do ISP DNS's work. They say, dude, talk to the hand. You go do it. Don't ask me. I'm a root server. I'm busy. Go talk to the .com servers. Here's their names. So ISP DNS server, what does it do? Goes to the .com servers. How many .com servers are there? 13. What's up with that? 13 root servers, 13 .com servers. Is that just these guys demonstrating that they don't suffer from trichodexophobia? The fear of 13? It's a bigger story. We'll see why. The .com server has the same answer. .com server says, dude, there's only 13 of me. .com servers are some of the most powerful systems on the planet. They are huge Oracle clusters. Because how many .com domains are there? You don't know? As of this morning, it was 103,985,000 exactly. I looked it up. This is what I do for you guys. So, seriously though, 104 million domains. You know, these are busy servers. They're not going to go look up a.bigfirm.com. They say, you know what? I have an idea. Since it's a.bigfirm.com, why don't you talk to the bigfirm.com DNS servers? Here's their names. Now it goes to the bigfirm.com DNS servers. It's called web2.manasseh.com. It gets the answer. Web2.manasseh.com knows the answer, hands the answer out, and now PC1 gets its answer. Does that make sense? Let's go back and think about that. Let's remind ourselves also of a phrase, authoritative. If you were to ask an ISP's DNS server, it might have the answer. Maybe somebody asked it for a.bigfirm.com, but that's just a cached answer. The only machine that knows is the machine that carries that information right on its hard drive, and that's called authoritative. That's just a review. Everybody with me on that? So there are authoritative requests and there are cached requests. Now, I told you this is the most simple-minded query in the world, and yet, we do this all the time on the internet. And yet, how many queries were involved? I count 8 there. Now, let's talk a little bit about what I'm saying in terms of troubleshooting. I'm saying that the best way to know how abnormal looks is if you know how normal looks. You can know how things are not working if you know how they work. So one of the things I'm going to say to you is get yourself network troubleshooting tools that let you look inside what's going on. That's Netmon. And then trace a healthy query. Keep that around. Print it out. Put it in a glass box, you know, in case of emergency, break glass. And when you're trying to solve a DNS problem, look at your healthy query that you did 6 months ago. Look at the unhealthy query and see where they start to diverge. Simplest thing in the world. Simplest thing in the world. The other thing I love about Netmon, and we're going to do it in a minute, the other thing I love about Netmon is that it lets you see things the way they really are. I remember when DHCP first came out in NT 3.5. So cool. I thought it was a Microsoft thing. I didn't know it was RFC'd. And this whole idea about where a machine just wakes up and it broadcasts to the DHCP server, that's a discover, and then it comes back to an offer. So the theory that I'd heard was, I'm reading the technical resource manual for NT 3.5, and it says, a client does a broadcast, any DHCP servers. One or more DHCP servers respond with offers. Then, and I quote, the NT 3.5 manual said, the DHCP client chooses from the many offers according to a number of criteria, and that's all it said, a number of criteria. And then goes back and says, I'd like that one, and then an acknowledgement, and then an acknowledgement. And so I want to know, what was those criteria? I spent a week with Netmon doing discovers, offers, request, acknowledge. Do you know what the criteria are? Whichever DHCP server responds first. That's the only one. So I'm not picking on Microsoft. I'm just saying, when people are writing up documenting protocols, sometimes they get a little lazy. When you see it in reality, that's how you know it's true. Has anybody ever sniffed DHCP traffic? Okay? It's interesting. Has anybody tried that with an iPhone on the network? It's really funny. I didn't know you could do this. But apparently the iPhone, its DHCP client says, hi, I'm so looking for an IP address. It would be awesome if I could get an IP address. And if I could get a nice lease, like 3 months, by the water, you know, something near the shops, you know, it would be just great. And the DHCP server says, yeah, you're mobile, so you can have 8 hours, and don't know about the shops. And apparently, I didn't know this. A client can talk back. Really, I so wanted the 3 months, because that's the only time I've got on my schedule. And, and they do this a couple of times until finally the iPhone says, well, I'll take the 8 hours. I suppose that's the best you can do. And so I didn't know that stuff till I started sniffing, you know. So it's just, anyway, I'm not the genius in this course. That's Laura Chappell. If you really want to know all that stuff, look at Laura's stuff. Anyway, so what's happening? Let's go back and look at those queries next level down. When we're talking to a server, we can't just talk to its IP address, because a server can do many things. How do I know I'm not talking to the web server? How do I know that I'm not talking to the DHCP server? Because, of course, we use ports. The way you identify DNS is a port of 53. That's why this is called the network files case 53. That's the DNS number. DNS also keeps track of the question. So what happens is, if I'm the DNS server, you talk to me on port 53. How do I talk back to you? I don't talk back to you on 53. You roll some dice, and you give me a random number between 1,024 and 65,535. That's a transient port or an ephemeral port. All UDP and TCP communications work like this. Now think about it. You're an ISP DNS server. You have like 25 outstanding questions. 25,000 outstanding questions. 250,000 outstanding questions at any moment in time. Your questions are going out. Answers are coming back. You need to be able to hook up the right answer and the right question. How do you keep track of it? There's a couple of ways. One is the port. You're expecting on port 5,000 the following answers. There's also something inside a package called the transmission ID, or a TXID is the way that it gets abbreviated. So that means on the way back in, the way we keep track of stuff is it's going to come in on the correct port and the correct transaction ID. Is that making sense? The transaction ID is 16-bit, just like the port. So it can be up to 65,535. It should be random. Let's take a look at just one transaction. Here's the ISP DNS server. Here's web2.manasseh.com. And yes, this is really ugly clip art, but I don't work for Microsoft. They have really sexy clip art. I just use the free stuff I can find on the web. Okay? So this one has, apparently both of the floppy drives are running on this one. So that's just maybe they're VMware virtual servers. Yeah, that's it. So our first server, and that's the ISP DNS server, has now found web2.manasseh.com. It's going to ask about a.bigfirm.com. It's going to say, hey, send me back the answer on port 3351, random number, and send it back on transaction ID 279 when you do. Once it does that, it starts listening. Once it gets the answer, it stops listening. The other server responds, and when the other server responds, it says it's the following IP address, and it comes in on port 3351 with transaction ID of 279. If those things don't match, the response doesn't come in. Does that make sense? We're going to see this when we look at the packets in a minute. Okay? So, questions on that so far? We all right? Doing all right? Good. Next. Internet protocols run on top of either TCP or UDP. Or, I guess it is A or B, one or another. What's the differences there? Let's just quickly review that. TCP is a conversation. It's a step-by-step connection and conversation. UDP isn't. I think I'm required by law to say that UDP is like a message in a bottle, which is actually a terrible metaphor, because not too many messages in bottles get to where they're supposed to get to. Very few of them do, in fact. And they're not very fast. UDP is fast, and it's quite reliable. It gets the job done. Why use them? Different uses. Some things are tied to just one. The web, of course, HTTP, that is tied to TCP. You can't do web communications over UDP. DNS is interesting. DNS will use TCP or UDP. UDP, just a message in a bottle. Here's kind of a metaphor, sort of a simile that I think about it, is why do we do these in different ways? Well, TCP gives us what? Sequencing and block checking, and it makes a certain amount of sense. It's kind of like going to a restaurant. There's a restaurant near my place. I like to go get breakfast there, Eddie's. It's like most restaurants. You walk in, they have to seat you because you're not capable of figuring out which seats are empty or not. And you know, they give you a menu, and they'll take your drink order, and then while you're looking at the menu, they're getting your beverage, whatever it is. Then there's the universal world symbol that I know what I want. You close the menu, you put it on the table. They come and take the order, and they get the beverage. Then they come back with the meal. And after a little time, they wait till your mouth is full and say, how's everything? Then, in the United States, and it's different here. In the United States, once they figure that it's time for you to get the hell out, they leave the check on the table. They say, take your time, and you then pay and you leave, okay? Not every restaurant's like that. Where I'm from in New York, we got a big part of New York, Manhattan. We have these big, long avenues. And on a nice day, it's lovely to walk from your hotel to wherever it is you're doing consulting. And there are zillions of little bagel places, mostly bagels, breakfast places, but mostly bagels. And they are tiny. They are smaller than this stage, 1/3 the size of this stage. And there'll be a counter. And you walk in. So the restaurant thing was like TCP, right? A lot of back and forth. We're doing lots of error checking, places to make sure. Think about this is how you get a bagel in New York. You walk in. There's a man behind the counter. The man has just recently come to the United States. And nothing wrong with that because his English is a lot better than my Arabic. You know, so I'm totally impressed by that, you know. And sometimes they'll say, what do you want? Sometimes they just look at you. And you say, I'll have a sesame bagel with chive, chive cream cheese or something like that. And he just turns around and doesn't say anything. You then walk over here. It's about like, 1.5 meters, 2 meters away. And you pay, and everything's fine. This freaks people out because they're used to like, good morning, sir or ma'am. How was your day? Oh, and mine is lovely. And what would you like? We don't do that. It's just like, bagel, cream cheese, whoop, bam. And if you even say it, if you want acknowledgement, like if you say it to the guy again, he said, you want two? Because there's no back and forth. This bagel shop, now why do they do this? What's that? It's faster, exactly. They're not making a lot of money on a bagel. Real estate in Manhattan is expensive. And they got to move like 40 million bagels every day or they can't make their rent. UDP, there's less back and forth, but it is faster. TCP says in its RFCs, it says we can go either way. DNS is one of the few protocols that will go either way. They're one of the few protocols that will either do TCP or UDP. But the RFC says do UDP where you can. And why? Because DNS is the hardest working protocol in show business. And so DNS, they'll heavily favor UDP. With me on that? Early DNS protocols, 883 and 1035, said you got your choice, but use UDP. That was the first rule. Second rule was if you're going to use UDP, those packets should be 512 bytes or smaller. That will turn out to be important. Why 13 addresses? Now I can tell you. What's DNS going to use, UDP or TCP? UDP. If you're going to use UDP, how big can the packet be maximum? 512. If you got 13 servers, 13 names and 13 IP addresses, that just about fits in 512. That's where the 13 comes from. If we gave them shorter names, we maybe could have done 14. So, make sense? All right. Now, let's have a wax on, wax off moment here. Why is this important? Many firewalls, when you buy them, have 3 rules built in. Because some of the things that will get you in DNS is sometimes we have security people. I'm a security person. We get a little excited about our jobs sometimes. Sometimes we work just a little too hard. And sometimes when we're setting up the firewall rules, we get some of those firewall guys that just don't want to talk to you, like, no, these are the rules, we're not changing them. Those are firewall nimrods, So if you got firewall nimrods, that's not so good. But I hope to give you some ammunition, and if there's security guys in the room, then this is helpful, okay? First rule, if it claims it's a DNS packet but it's fragmented, block it. Is that a good rule? If it claims it's a DNS packet but it's fragmented, block it. Is that a good rule? If it's a DNS packet, what is it probably, UDP or TCP? UDP. How often is a 512-byte UDP packet going to be fragmented? Like never. So that's reasonable. Remember the whole Smurf attack and the teardrop attack, ages ago? I can see why that rule's there. Second one says if it claims it's a DNS packet, but it's TCP, block it. Is that a good rule? It's a good enough rule because 99.9% of I don't like the rule, but you're not going to notice it because 99.99% of the time it's UDP. How about this one? If it claims it's a DNS UDP packet, claims it's UDP, but it's larger than 512 bytes, block it. Reasonable? From what I've told you? Is it reasonable? Yeah, right, exactly. Okay. Let me give you an example where that wasn't a good thing. It's like 2002, I'm doing some AD consulting someplace. And I've been there Monday, we're working with the Active Directory. I come in Tuesday, and there's some people waiting for me. I said, hi. They said, some guys here from the DNS group. I said, I didn't do anything because you guys wouldn't let me touch the network. I just told you what to do. And he said, no. This is just, they want to know if you'll answer a question because they read your book. All right. I'm getting paid by the hour, so sure. And I said, we have a problem. I am changing names, by the way. I don't name actual clients, okay? They say, we have this business B2B relationship with Yahoo. We're trying to resolve www.yahoo.com, and we can't resolve it. We can get anywhere else on the internet, but we can't get to www.yahoo.com, and we could do it yesterday. You with me on this? Okay, put your troubleshooting hats on. What's the first question you ask? Well, I know it's DNS, but okay, but you know, so DNS isn't working. Sorry? No. Yes, those are good questions, but no. When something worked yesterday and it doesn't work today, what did you change? Exactly. What did they say? Nothing. And it's true. Nothing. It was just nothing. Here's what had happened. Yahoo, not their real name, had added a 14th, because they're big, they're busy, so they've got 13 DNS servers. They added a 14th DNS server. Then we found out that the guys at this company had firewall nimrods. And the firewall guys said, one of the firewall rules is, if it's TCP and it's DNS, drop it on the floor. I didn't tell you this, sorry, but you could have guessed it. If DNS traffic won't fit in a UDP packet, what do? It's got to fall back to TCP. DNS falls back to TCP when UDP won't do it. By adding the 14th DNS server, they forced them to go to TCP. And these local guys had a dumb firewall rule that said, if it's DNS and it's TCP, no good. Make sense? You know what? In the last 10 years, I've seen that happen so often. Just so often. It's astounding. So let's see how we did find these things out. One of the tricks to finding these things out is let's do some netmon, okay? So I have a lot of slides about this, but I'd rather just do it live. So let's do that. Almost live. So I'm going to start Network Monitor. This is a free download from Microsoft. Before you ask me, Wireshark is fine. They're both good. And I would never speak ill of Wireshark because Laura is always listening. So, no, seriously, they're both absolutely great tools. So we start out, looks like this. This is why people stop using netmon, is opening screen looks kind of scary. So our first thing is, what is this? Well, here we're looking at what do you want to sniff the traffic on. So here's my wired Ethernet connection. There's my wireless connection, and there's something else. And I've cleaned off a lot of the IPv6 stuff. I run IPv6, but I've turned the 6 to 4 adapter off, the ISOTAP adapter. So I'm saying, if there's a lot of stuff here, just uncheck so you only get what you want. Okay, so you're just looking for the things you want. And over here you see P mode. Your network card hears everything that comes at it, but it ignores everything except for things directed to it or broadcasts. If you activate a certain kind of driver called a promiscuous mode driver, which is not nearly as much fun as it sounds, then it will bring in all traffic. You don't want that in this situation. Because how many of you, again, you've all looked at netmon. What's the biggest problem? Too much stuff. Too much stuff. So don't turn on P mode unless you need it. Are we okay so far? We got any questions? All right. So I would then say I'm going to, maybe I'd uncheck wireless or whatever. I'm not going to do a capture right now, but I've got a capture that I've done. So bring that up. And now, what's going on here? Well, over here we have network conversations. That's okay if you're using TCP-based stuff. I don't need it, though. So I'm going to get rid of that. And what am I left with? I've got a section here called Display Filter. That's good. We're going to use that. Display Filter, that's going to be valuable. Then we see frames. These are all the frames that I captured. And then down here are frame details. That's good. Then over here, though, there's hex details. And I'm geeky, but not that geeky. Not when it comes to this stuff. I'm going to close that up. And then there's frame comments. And this can be a lot of fun, because if there's a frame that's kind of ugly, we all make comments and laugh about it, but not today, okay? And that's the way I like Netmon. So that way, all I've got here is my display filter up top. I got my frame summary, and then my frame details. Okay so far? All right. But there's still a lot of stuff there that I really don't want. So it would be nice if there were a way to kind of trim it down. By the way, when you saw me rearrange the frames, when you start up Netmon, it will restore the default. You have to do it 3 times, and then Netmon believes you. I'm not kidding. So then if I click, so here I've clicked my first item. Now what do we know just from here? By the way, also I've rearranged the columns. When you get this started, there'll be lots of extra columns about time and time offset. You know how to remove columns. I mean, do whatever works for you. This is what I like. I like having the source IP, the destination IP, the description, and maybe some other details over here. Because this is just the summaries. This is just, and I want to see just the DNS traffic. How am I going to do that? I'm going to go up here, and I'm going to create a filter that says, just show me the DNS traffic. How do I do this? It looks a little like kind of a programming language, a very, very, very simple programming language. And when you see them, they're a little ugly, the filters. But don't fear them, and here's why. They did something really cool in Netmon. You can go into that frame summary, up here, into the display filter. You can click up here in the display filter, and this is the trick. It's an Easter egg. Press F1, and you get help. Who knew? So they did a great job on the help there, and when it sees you're in the display filter, it shows you like 150 examples. I almost never have to write a filter. And you want to see how hard it is to get the DNS traffic? Type DNS. And then I'm going to click Apply. And now it's just the good stuff. So that's pretty neat. So we're looking at a packet here. And what do I see? Source, 192.168, 1.125. That's obviously my source test machine. Going over to, what's that the IP address of? That's the IP address of one of the root servers. Pretty cool, huh? You know the exact address of a root server now. You can go visit it. So many famous things, you can't find their address, you know. So, but this is right there. And it says a DNS query. There's a DNS query ID. Remember we talked about the TX ID? Everybody else calls it a TX ID. Netmon calls it a query ID. And then if we come down here, it breaks the packet up for us. Inside of it is Ethernet, because it's Ethernet traffic. We don't care much about that. IPv4, we knew that. It tells us a little bit. We get some source and destination. That says our next protocol is UDP. UDP, that's not surprising. We expect to see UDP because it's DNS. What do we see here? Source port equals whatever. Destination port equals 53. That's that ephemeral port. There's my transaction ID. Where's the transaction ID? Right there. Is this making sense so far? How this relates to our expectations? And then from there, I can start looking at the DNS packet. And I want to spend a little time on this. Now, I'm going to do a lot of talking for the next few minutes. If you want to make notes, that's fine. But everything I'm going to say is in the following PowerPoints. Because when I'm done with this, I'm going to skip past like 15 PowerPoints. Because that's the text that backs this up. Every DNS packet's going to have the same kind of look for it. It's got a query identifier. That's that TX ID. It's going to be a value between 0 and 65,535. Then there are 4 parts to it. This is a table of contents. Every DNS packet, and by the way, when I say query, in the DNS world, everything is a query. The original question is a query. The answer is a query. It's like in SQL. You create a record with a query. You delete a record with a query. So there's queries that are queries and query responses. RFCs are written by university professors with a lot of free time. And they resent the fact that you make more money than they do, so they try to make your life as complicated as possible. So, but this is the key. There's a question, an answer, authority. That really should be called authority. and then additional. That's qua. 1 Q, 3 A's. What's the question? It's the original query. Tell me what a.bigfirm.com is. This is my original question. The question's in there. Is there an answer? No, of course not. If I had the answer, I wouldn't ask the question. So there's no answers, there's no authority, no additional counts. Okay so far? This is the easy one. It'll get a little ugly in a minute. Only a little, though. Then our response is going to be our next packet. You see where it's coming from? Again, there's our 199 address. That's our route. Excuse me. That's our root server. What do we got? Well, there's a question. Why would the root server be asking me a question? It doesn't really. Like in your 4th year of school, 9 years old or something like this, and they start giving you questions, history questions. Do you ever get told, always use a complete answer? So if the question was, what year was George Washington born? You're not supposed to write 1731. You're supposed to write George Washington was born in 1731. That's a complete answer. DNS paid attention in 4th grade, and so as a result, DNS always sends back the question in response to the following question. Is there an answer? Is there an answer? No. Why? It's the root server saying, dude, figure it out for yourself. These guys can help you. So it's basically it's like going to a government office. The idea is you don't actually get any help, but you get sent to another office where there'll be no help also. And then they'll send you, that's not always true. At least that's in the States. I don't know if it's true here. So. Anyway. It says, look, don't ask me, ask these other guys. And you get these things called authority records. An authority record basically means name server. So the notion is, I'm the root server, I'm pushing you off, these are the name servers to be the next guys that you ask. Every kind of query looks like this. Again, I'm showing you the easiest query in the world. The exact same thing happens under the hood when you're looking for domain controllers and you're logging on. I mean, they're different records, they're SRV records, but still, the same basic approach goes on. So what do we got here? It warns me that I have 13 answers. Why 13 answers? Because how many .com DNS servers are there? 13, right. And then there's additional, what's that? Let's take a look at that real quickly. Okay. So I've got authority records, and an authority record looks like these are, let me scroll this down a little bit. Authority records means here's the names of the .com DNS servers. He's type NS, name server. There's a name, A.GTLD, B.GTLD, blah, 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 till we get to M. 13 of them. Why 13? Because of UDP. Making sense? Yes, no? Speak to me. Okay. But then we get the additional records, and what's that? It could be anything. In this case, the notion is, I just told you there's a DNS server named A.GTL. Your next question is going to be, what's the IP address? I know I did this quickly. Does anyone remember? How many name servers did it give me? I just told you that. 13. Did anybody remember how many additionals there were? It wasn't 13, it was 14. How come? Because one of the root servers on the internet, what's that address? I know you guys are like, IPv6. I don't know what that stuff is, but there's an awful lot of colons there. And I know what comes out of colons. Anyway, so at this point, there are 10 of the .com servers that have IPv6 addresses. So that's going to start changing, which is going to lead to a question I know you want to ask, and I'll get to it later. So, finally, we get down. So what have we seen? I asked the root server a question. I got sent to the .com servers. The next thing I'm doing, as I said to you, talking to a .com server. See that? Talking to i.gtld.servers.net. That's where I ask the question of the .com server. Hey, what's a.bigfirm.com? The .com server says, go talk to web2.manasseh.com, and I get an answer. Is that making sense? Was that hard? I mean, is there anyone here who thinks that was too hard? I mean, because what's great about that? Think about all the troubleshooting tools you work with, like NS lookup. unless you put it in debug mode, NSLOOKUP doesn't tell you any of this stuff. And even then, when you do put it in debug mode, it's like, could you explain it in a harder fashion? This seems very clear to me. I can follow the track. If things go wrong, I can see what. Does everybody see that? Okay, good. Please, real quick. Why do you only get the v6 address for one of them? That's because I took this particular track about a year and a half ago, and only one of the .com servers had a v6. Now 10 of them do. What's the next question you want to ask? Will it fit? Thank you. Will it fit in 512? Hang on. Good question. No, it's an excellent question. It's good to have a shill in the audience. Have we ever met before, sir? Okay, that's right. So, absolutely, you bet. So, I've only got dollars, I know, but anyway, yeah, I know, not good. So, how much in a euro? $1 billion. Anyway, so I'm going to talk about that in a minute. But wouldn't it be great? Wouldn't it be great if we could have UDP packets bigger than 512? I say, friends, wouldn't that be great? Because I mean, 512 in 1984, back in the late 1900s. I mean, but the internet's changed. If only there were a way to make those packets bigger. Which leads me to my next topic. So are we good with Network Monitor? Any questions on that before I go? Please, real quick. Why I? So the idea is that it depends on what your DNS server does, but most of them will essentially do a round-robin-y kind of thing, where if it really depends, because it's interesting. It depends on whether it's a Microsoft DNS server or a bind server, and a lot of them you can configure the way they work. But you know the answer, right? Is that clearly if I'm going to give you A, B, C, D, E, F, you don't want everybody hitting A. So it's just logic inside the DNS server. Okay? Good question. Other questions, anybody? All right, good. I'm going to leave that, and I'm going to skip past a bunch of PowerPoints. I'm not skipping past them. It's just they're saying what I already said. I know sometimes when I skip slides, even if they don't say anything new, people say, you skipped slides. So, okay. Look, there we go. Come on. You can do it. Computer. Yes. There we are. Okay. So that's if you want to turn off V6. There's a little bit less chatter. I do not recommend turning off V6, but for a test, it makes sense. See, there's our netmon. Looks exactly the same, pretty much. There's the reference to P mode. Okay. This is where we're cleaning up the windows. Here I'm going to do a ping to a.bigfirm.com. There's building my DNS filter. So everything I showed you we're doing here, that's a snap. It's not exactly the same screenshot. It's not exactly the same trace, but that's the same idea. Root servers, sidebar. How many root servers are there? There's not 13. They try to keep it to 13 because of the 512. In actual fact, as of this morning, there are 319 root servers. Essentially, there's 13 IP addresses and then an IP load balancing tool on the front of it. But there's actually 319. And that number grows every day. That number was only 237 last year at this time. We lost, believe it or not, we lost 40 root servers when the big tsunami happened in Japan. Japan has been an important part of the internet even back before it became the world's internet, when it was just the United States government and academic and defense network. Japan was an important part of it. And I don't even know why they took all those servers offline. It may be that, I don't know, because Japan was in the process of really shutting down a lot of their nuclear reactors, that I really don't know what the whole story was. But for a good long time, it was down, and then it's really been growing very quickly. So we're going to see more and more root servers. And here we did the resolution of bigfirm.com. We looked at the QA. Here I'm zeroing in on the one question. Here we got our answer with multiple name server counts and responses. And then we do our query. That is the response from bigfirm.com. There's the answers there. Again, same stuff that we've already seen. So is everybody okay with those slides? They're just backups to what I did. Troubled? Quick question. Talk to me. Yes? No? Anybody? Okay. All right. Good. I want to also point out another issue you will get in Active Directories. How many of you ever run into trouble with dynamic DNS registrations? It happens sometimes. That's what a good one looks like. Go back to your network and do a trace. Do a trace where you're going to look at what a good one is. Keep that for a reference. So that part of troubleshooting, what am I saying to you? Use netmon. We saw how to do that. Understand QA. Understand what the packets look like. Understand the queries. It was a simple query, but it's the exact same query for anything you do. And who's the busiest DNS servers in the world? Your Active Directory servers. Why? Because of the small caches. Are we good on that? I kind of want to go to phase 2. Phase 2 is supposed to be shorter. I just want to tell you about a couple things. Phase 2, extensions to DNS. We need more space in DNS. There's only room, only 7 bits for flags in DNS. We've used 6 of them between '84 and now. If 2 people come up with a good idea, we're screwed. So we need more space for flags. That's why 1999 saw RFC 2671. Now, you will read blogs about this, which are wrong, that will tell you that Microsoft DNS only started supporting it in R2. That's not true. That is not true. Uh-oh, whoops. I thought I was plugged in. Oh, boy. You know, this is what happens when I start talking to you guys early on. Battery, cable. Oh, look. When are we getting wireless power, damn it? You know, I learned everything I know about technology I learned at Star Trek. Star Trek, they just beam down to some planet where they've never seen anything before. They put 2 boxes next to each other and blue beams stab out back and forth, and stuff works. You never hear, you know, the little data pads they carry, ever like, Mr. LaForte, bip, bip, bip. Frack, I didn't recharge the thing. That never happens. Never happens. Thank you all for helping me to manage my presentation. Couldn't do it myself. So our big items, we want more flag space and bigger UDP packets. So we're going to get bigger UDP packets and more flag space. And these things are important. Anybody here looking into DNSSEC? If you're not looking into it, you should be. DNSSEC can't work without this. Big UDP packets can't. So here's my problem. I've got DNS. I'm a DNS server. I understand this new DNS thing. I don't want to break existing DNS. Don't want to break existing DNS. So if I'm DNS smart, and I'm talking to a DNS server that's not DNS smart, how do I know? Since it's a new protocol, I can't require that the old steam-driven DNS servers are going to respond to me. Here's the way we do it. So what have we seen so far? Question, that's just the question. Answer, that's a simple answer. Authority, that's name servers. What was additional for? Anything we want. So additional creates this new kind of record. It's not an A record. It's not an MX record. It's not a CNAME record. It's not any of those things. It's called an opt. Opt as an optional. What does it do? Nothing. So here's the deal. I'm going to query you about a.bigfirm.com. What do I say? I'm doing a query. Type A for address, a.bigfirm.com. That's an old query. Even if you're a 1934 DNS server, we had them. We just didn't let the rest of the world know about it. So 1934 DNS server, you say, what's a.bigfirm.com? It knows how to answer that question. But the problem is, if you're an old server, what's the biggest UDP packet you'll do? 512. So what I want is I want to say a.bigfirm.com, and by the way, I know eDNS. Let's go big UDP. How do I do that? I say, here's my request. It's a.bigfirm.com. Oh, by the way, here's some information. I have an opt query for you. What's opt? It doesn't do anything. Let's say you're an old DNS server, and I say, I do a query, opt. If you've never heard of a query, if I say to you, if you're a DNS server, and I say, do you have the XYZ record for www? There's no such thing as an XYZ record. What will a DNS server do? Some kinds of servers would say, error, that's an error, he said something wrong. What does DNS do? Well, manners books, you know, like how to behave. I've never read one. But I'm told that in manners books, if someone does something like kind of icky in public, the best thing to do is just ignore it. DNS does that. In the RFCs from the ones back in 500 BC, when DNS was first developed in Greece, then if they'd only stayed with it, who knows? If you send a DNS server a request for a record it doesn't understand, it just ignores it. So here's the trick. I just asked you a.bigfrom.com. You're like, yeah, I know how to do that. I say opt. You're like, no idea. But you respond, and everything's fine. Any error messages? Any error messages? No. If you are eDNS aware, though, I say a.bigfrom.com, opt, I can do 4,000 bytes on UDP. You come back and say, here's the answer. I can only do 1280. That's the negotiation. The negotiation is, I got a question for you. And by the way, I can do big UDP. Your answer is either, here's the answer and I don't know what you were talking about, or here's the answer and I can do UDP too. Okay? So this is kind of cool. And let's see how that looks. So let me tell you about a.bigfrom.com. What I did with a.bigfrom.com was I deliberately created a record that has 50 A records in it. And 50 A records means it's way bigger than 512. You can use this as a test tool. So let's take a look at this. Here's the original query. You've seen the query before. Look at the additional. This is new. So originally we had one question, 0 answer, 0 authority, 0 additional. Now we got 1. See the opt? That's called an eDNS probe. I come back with the answer and it says, here's my answer. It's a UDP answer. Whoa. The length is 850. Why? Because further down. So I'm eDNS aware. I came out. I gave you the opt. You came back and said, Groovy, let's you do UDP. And you responded to me. And you sent me a UDP packet that was how big? Bigger than 512. Make sense? All right, good. Notice also, you can tell the difference. When you look at Netmon, if you're talking to an older, dumber DNS server, it kicks over to DNS over TCP. Does that make sense? Okay, why do I care? Here's why. Now imagine this happens. Microsoft has supported UDP ever since 2000. Microsoft has supported eDNS since 2003. It's only with 2008 R2 that they started the conversation. Microsoft DNS servers never sent ops. They never started the conversation. They'd respond, but they never started the conversation. Now let's imagine I'm sitting at my computer. I have my brand new 2008 DNS server, and I query www.yahoo.com. I'm making this up, and I send an opt. And Yahoo says, no problem, sends me a big UDP packet. Is everything fine? So far. So far, we're following the RSC. Everything's going to be fine. What happens if your firewall, though, you with me? What happens if your firewall says, if it's DNS and it's UDP, and it's bigger than 512, uh-oh, we're under attack, shields up, drop it on the floor. Does everybody get that? You'll read a lot of blogs that say to do that. This is wrong. DNS command, -config, that should be enable, sorry. Enable eDNS probes, 0. Don't do that. That says never start the conversation with eDNS. eDNS makes a whole lot of sense. We need bigger UDP because we've got more servers and the internet's getting busier. All right. So why bother with eDNS? We need it, DNSSEC needs it, etc. I'm going to finish off. I've got a few minutes left and talk to you about a tool that I think everybody should have. It's called Dig. We use NSLOOKUP, and boy, it's just not the smartest, it's not the smartest DNS product in the world. It won't look for alternate DNS servers. If you have a preferred and an alternate, it will not go to the alternate. Just a lot of dumb stuff that it does. The bind guys have had it for the longest time, and you can get it too. Just go to isc.org, as it says there, extract the files, and pull down all of the files whose names start with dig or that are DLLs. Stick them in a folder on the path, or just put them in System 32. That way you've got a command line tool that's always there. Give you some dig syntax. Let me show you a couple examples. If I fire up a command prompt here, of course, before I do any DNS testing, what's the first thing I do? ipconfig /flush DNS to be absolutely sure that I'm not dealing with my local cache. And here's the way you do a query with dig. If I say dig, www.microsoft.com. Just the easiest thing in the world. That just says do an A record query. If I wanted to see an MX, I just put the record type after it. What if I wanted to say don't resolve it with this DNS server, resolve it with a DNS server at web2.manasseh.com? That's in the PowerPoint. That's kind of cool. So we can choose the record type. We can point it at a particular server. If I don't do anything, it will go to my preferred, and if that fails, my alternate. Questions? Good so far. Let's see what the output looks like. I don't know if I don't want to do this because if my DNS server is not working, I don't want you to laugh at me. So I'm just going to go with the one in the building here. Look at the kind of information we're getting here. Ah, question section, answer section. You can turn on flags to see all that stuff. That's a bit easier than Netmon. Now, it's not showing you all the intermediate queries. Does this make sense so far? Wait, there's more. I can force this thing to go UDP or TCP, because let's take a look at a.bigfrom.com. There's all our data. I told you there's a lot of records in there. So it looks like everything worked, kind of. But maybe not. Here's another nice thing to do with Dig. If I said a.bigfrom.com, now, my DNS server will do eDNS. If that's the case, should I be able to query my 850 byte item without any trouble? Well, it'd be nice if I could force it to use UDP. It'd be nice if there was a way to say you have to use UDP. Well, to that end, if I just say plus VC, virtual circuit, that forces me to use TCP. If I say plus no VC, that forces me to use UDP. Think about this. I'm dealing with a DNS server here in the building that I don't know. Should it be able to handle 850 bytes of UDP? I hope so. But maybe they got firewall nimrods here. Want to test it real quick? Because I've told you this is a problem. It really is. Here's your test. Use my record, a.bigfrom.com, do plus no VC. In a world where everything's fine, where the firewall's not stupid and the DNS server's not stupid, when I go up top here, let's see what it says. Do you see it? Dig a.bigfrom.com plus no VC, truncated, retrying in TCP mode. Sensors have detected firewall nimrods on board, Captain. So they've got a firewall they bought from Best Buy, plugged it into the place, and that's pretty much it. You know. So, and that is about as much as I had for you. I've got a couple more slides on DC Diag, but it's not particularly important stuff. Here's the point that I wanted to make. So, what do we see? We looked at the most simple query in the world, but it's the same as any of the ones that you do for keeping your virtual machines running, your private clouds, your Active Directory, etc. Go look at some good ones, keep them around, have them as reference entries. Always take pictures of what normal is so you can look when you can see what abnormal is. Get a hold of Dig, put it in your system, start using it. It is so much better. You'll become totally addicted to Dig instead of NS lookup. When I'm on a server, I'm on a machine that's got NS lookup and not Dig, I become a downright child. I want my Dig. I'm going to download Dig. Anyway, so do you understand eDNS? The only reason I told you this is that if you do that test back on your network, I mean, there may be some other reason why it's got to break it up into TCP. But if you're out on the internet and you're talking within your network, try this. You will see that a plus no VC will always work. You'll be able to get big blocks. Always use a.bigfrom.com. That's a great test, or build one of your own. But if it does force you to break it up, look at it. Is it just that you've got eDNS turned off on your DNS servers? If so, turn it on. Enable eDNS probes. DNS command /config enable eDNS probes 1. Turns it on. It should be on by default for your R2 boxes. And by the way, turn it on for your O3 boxes. Because, oh, by the way, the kind of queries you guys do. How many of you have more than 3 domain controllers? You have enough SRV records and enough additional records that when you do a logon in the morning, guess what? It's more than 512 bytes. How busy are your domain controllers first thing in the morning? A little. Why make them do TCP when they could be doing UDP? There's an immediate fix you can do. If you got more than 3 domain controllers, don't believe me, run it on Netmon, you'll see that it gets above 512. You'll see that it kicks back to TCP. Make it stop doing that. If you have a Microsoft DNS server from 2003 or later, it'll do eDNS and happily. Turn on eDNS probes and try this VC test, and if it doesn't work, talk to the firewall people nicely, because you know they can do bad. They read your mail. I've got another talk today, last session, about just some Windows power tools you might not know about. Again, I want to thank you for coming first session. Enjoy the show, and remember to use this knowledge for good and not for evil. Don't forget the evals. Thank you.